In this lesson, we're going to look at the functional groups alcohols and amines. So alcohols are organic compounds that have the functional group hydroxyl, or OH, attached to one of the carbons. When we name alcohols and when we draw them, we're going to identify first the root, or the longest chain that has the hydroxyl group attached to it. Then we're going to identify the suffix of that based on the number of carbons in that chain, and we're going to change the ending of that parent alkane to OL. So we're going to chop off the just the E. We're going to chop off the E and then add OL to that. And then the prefix, so we're going to take any side groups, any alkyl or halo side groups, and add those on with the name and number, including any prefixes for those for more than one of a particular alkyl or halo group. Okay, so over here we have a compound. There are 7 carbons in total. And when we look at the longest chain, so if I just go straight across, there are 4, so I can get more than that. If I go 1, 2, 3, 4, 5, 6. So that is going to be my longest chain, these, and then I have a methyl group that is attached. And for numbering, I'm going to start from the right because that gives me the lowest number for the attachment of the hydroxyl group. So I'm not going to come from this end because then this is going to be the 6th carbon. So what I have is hexane would be the alkane, the parent alkane. And then we have the hydroxyl group. So we're going to chop off the E from hexane and add OL. So hexanol. And we're going to add in the 1. So the all is what tells us we have an alcohol, or the hydroxyl group, and it's on the 1st carbon. So that's going to become hexane 1-ol to give us the position of the alcohol. And then off the 3rd carbon, we have a methyl group. So this is going to be our prefix, the 3-methyl hexane 1-ol. So we've got the parent chain, the longest chain of carbons is 6, so hexane. The alcohol is attached to the 1st carbon, and then we have a methyl group that's attached on the 3rd carbon of the parent chain. So when we talk about alcohols, there are 3 different types, and it's based on where that hydroxyl group is attached. So the carbon it's attached to, how many other carbons is that carbon attached to. So a primary alcohol has the hydroxyl group attached to a carbon that only has one other carbon attached to it. So when we use R as a group, what we're meaning is any chain of carbons that continues on over there. So there's going to be a carbon here and then potentially multiple carbons after that. But the only thing we're concerned with is this carbon is only attached to one carbon. So it's got 2 hydrogens and the hydroxyl, but only 1 carbon. So a primary alcohol is a hydroxyl, or OH, attached to a carbon that is only attached to one other carbon. A secondary alcohol then has the hydroxyl group attached to a carbon that is attached to 2 other carbon atoms, and then we still have a hydrogen. And a tertiary alcohol has the hydroxyl group attached to a carbon that is attached to 3 other carbons. So this carbon atom would have no hydrogens attached to it because it has 3 carbons it's attached to and the hydroxyl. So we've got the full 4 bonds made up there. So primary attached to 1 other carbon, secondary attached to a carbon that's attached to 2 other carbons, and tertiary attached to a carbon that's attached to 3 other carbons. So amines are similar to alcohols but they have a nitrogen atom. Now the difference is the alcohol has to be an OH group, so the oxygen has to be with hydroxide. With an amine, the nitrogen itself is what's important, and then the nitrogen can be attached to multiple things, and that will help us determine the types, which we'll see later on. So the naming and drawing rules are going to be similar. We're going to identify the root or the longest chain that has the nitrogen attached to it. We're going to use the ending amine, and we're going to indicate the position that that nitrogen is in. And then we're going to add any alkyl or haloside groups at the beginning. For anything that is attached to the N instead of a number, so the numbers refer to one of the carbons, and if we have an alkyl side group attached to the nitrogen, then instead of the number, we're going to use N to say that it's attached to the nitrogen as opposed to one of the number of carbons in that group. So here is an example, and we have our nitrogen over here. So we are looking for the longest chain of carbons that nitrogen is in. So if we look over here first, we have three sort of separate areas that we can look at here. And so the longest alkyl group here is this one. So we've got 1, 2, 3, 4, 5 carbons attached to the nitrogen here. We only have 3 here and 2 here. And then this is a group that's attached to that longest chain. So that is, if we start our numbering from here, we've got 1, 2, 3, 4, 5, 6, 7 carbons, and the N is attached to the third carbon. So we have a pentane with the amine or amino, the nitrogen, attached to the third carbon. And then attached to the nitrogen, we have an ethyl, so 2 carbons, F, and then 3 is prop, so also a propyl group. So we have an N-ethyl and an N-propyl group attached to this heptane that on the third carbon has the amino group. So our prefixes, we have N-ethyl, N-propyl. So those are our side groups that are attached to the nitrogen. And then we have a heptane 3-amine. So we have 7 carbons. On the third carbon, we have our nitrogen. And then on that nitrogen, we also have an ethyl group and a propyl group. So similar to alcohols, we have primary, secondary, and tertiary amines. So a primary amine is when the nitrogen is attached to 1 carbon and then 2 hydrogens. A secondary amine is attached to 2 carbons and 1 hydrogen, and a tertiary amine is attached to 3 carbons and no nitrogens. And so in these examples here, we didn't use R for some side chain with some number of carbons. They used methyl specifically, but it doesn't have to be methyl. It can be any group. The rest of what this carbon is attached to doesn't matter. So the important thing is 1 carbon that it's attached to. Here as well, this can continue on, or it can just be a methyl. Same with this side. And they don't have to be the same. They don't have to have the same size side chain. So if we look back to the example we had here, this nitrogen is tertiary because there are 1, 2, 3 carbons it's attached to, and they're all different size chains of carbons.